just slander on YouTube.
All right, my friends, let's settle in. Please stop doing stuff, for God's sakes. Stop doing. All right, so let's just settle in. Come into this room. And just watch what happens when you stop doing. Bring your attention to your breath. Where do you notice your breath the strongest? Your nostrils, your chest, your belly. Focused can you get on just one cycle of your breath? So watching the details unfold all through the inhale and all through the exhale. Cool how it just happens. If you try to intervene, it just starts to feel weird. Excellent. That's a great practice, my friends. Thank you. So, I thought we could warm up with a couple of problems that are very much like the homework, just to see where we're at and maybe strengthen some things that we talked about a little bit. So, and I also kind of want to push things forward too. So the current homework, first off, remember we're gonna have a little quiz on Wednesday, and what is on that quiz is up in world class. There's two things. There's that little box at the top of page 30. Is that, I don't know where that, the little box of information. Yeah, it is, in the top of page 30. So no notes, like having you copy this from the book is not much of a quiz, right? So we wanna have this statement completely memorized, be able to just spew that off with no thought, or thought because you understand it. And then there was a problem. I'm going to ask you to solve a quadratic equation. And there's a problem that I put up. Who was it, Christian? Were we working on that earlier? Yeah, there's a solution up for it now too. And that solution should now be correct. But we're gonna practice doing that today, and then tiny little bit of pushing forward. But other than that, I kind of want to work on, I want everybody to have a chance to work on stuff while we're here in a supportive environment today. So let's warm up. Could you please find the square root? So, and when I say this, I'm thinking of the plus or minus version. Well, hell, we'll just tack them in front. I think it's negative 16i that I want. Yeah. So negative 16i. Let's just see what we can do with that. And then we'll go through it, and you know, karma free. This isn't a quiz. This is just for you to see where you're at in doing this stuff. talk about other ways to do this besides the one that I showed you. We'll just wait. We'll just do that together. I didn't really talk about that second route, but this is what the book does, I think. That Christian, that's what you were kind of like following along with. The polar form is, I don't know which one's the most work. Polar form's actually way easier. Yeah, for sure. So let me just kind of back off. Does this make sense from here to here? And if not, let me know. Yeah, we're good on that, on the polar form. And you could do 3 pi over 2 as well. Totally cool. If you had said, excuse me, yeah, 3 pi over 2 is the argument. That's okay, we get the same answer. I like keeping things small, so this is all good. So this is just plus or minus the square root of 16 times e to the, just take half the argument. So we're almost done when we do that. I just took half of the pi over 2, square roots cut the angle in half. So it's plus or minus 4 e to the negative pi over 4i. And then from here, I would just go to cosine plus I sine form. And work this through. So it's plus or minus 4 cos minus pi over 4 plus I sine minus pi over 4. And maybe you've got your unit circle table or some kind of, you got it in your head. And you got plus or minus 4. This is going to be, that is just square root of 2 over 2. And then that's minus square root of 2 over 2i. I think so. Let me know if you see bad stuff, let me know. And then this, just I would multiply that 4 through and we get plus or minus 2 square root of 2. And then this is the opposite, so I put minus plus 2 square root of 2i. Those are both my square roots. That got a nice smile on, looking happy about that. I love that. Are we good? Anything you want to talk about with that route? Yeah, awesome. Oh man, I like the confidence that I'm seeing. Ella, yes ma'am.
Only thing I don't get is like the plus minus, like why is that flipped? The plus
Here.
minus, it's like on the final answer.
Yes.
Polar form, it's plus or minus 2 squared root of 2 and then it's minus plus.
Yes, because, so notice that in this thing, this is the, whatever this is, it's the opposite sign of this first part. So when I take the plus or minus times this, it's just plus or minus, but this flips it. So what I mean by this, Ella, is that it's either a plus and a minus together, or the first one is a minus and then the second one is a plus. So they pair up like that. Does that make sense?
Mm-hmm.
Yeah. It's not 4 different things, even though you can kind of get the feeling that it was. It's just 2 different. Yes. So maybe that's a little unclear. Great question. Okay, cool. And then it looked so good in my mind that would just flip up. Let's take this route. Let's say you don't know polar form. And this is kind of a cool route too. I like it. You basically leave everything in rectangular form, and you're looking for the x plus iy, whose square is negative 16i. So just write that out, and then FOIL out this left side. You will get this, x squared minus y squared for your real part, right? Because that comes from I squared y squared, gives you a negative 1. And then 2xyi, and that needs to equal this side. So that means that this part has to be 0, x squared plus y squared minus y squared has to be dead, and 2xy has to be negative 16. So far, so good? You know, real cool on that? Yep, okay, good. Cool, all right. So, when I started going here, I was thinking, okay, well, there's 2 cases here. What if x equals y? Why is this impossible? Why is that impossible? X and y are real numbers because the I is already taken care of. X is just a real number times, the y times I is the imaginary part. So y is real. How can I rule out the, yes?
Well, in the 2xy equals negative 16, if they're the same sign, they're going to make a positive number.
Exactly, right. So this, if they're the same sign, I can't have this. So impossible because 2x times y equals a negative number. So they have to be opposite signs. So we rule that case out. And we already see that they have to be opposite signs, right? There I've got the plus and minus, or the minus and the plus. So must have x equals minus y. And now I'm going to plug that into this equation. I'm going to replace the x with minus y. I'm going to replace the x with minus y and solve for y. So what we get here is y squared is 8. So y equals plus or minus 2 square root of 2. That's looking familiar. So let me stop. Let me know how this feels, or if there's any questions how to get through here. What's up? All right, sweet. So if y is equal, there's two options for y. X is going to be the opposite of that. So here we get x is plus 2 square root of 2 and y equals minus 2 square root of 2, or the vice versa. And we get the same answer we had before. So thanks to Christian for coming by my office and reminding me that's a way to do this, because it's cool. Desperation hits, you don't need trig. Just need some algebra. There's no need for desperation in this class, though. Should be no desperate moments, hopefully. Okay, any questions on that, my friends? I want to finish this then and talk about a quadratic, because that's what I'm going to ask you to solve on Wednesday. And I'm not going to assign any homework on this, because the homework is getting ready to just be able to do this. So let's look at an example. Well, actually, let's just look at the general rule. So if I have az squared plus bz plus c equals 0, good old quadratic formula still applies. I just, like, in the last couple of years, stopped writing this as a big ass fraction. You know, like all over two. Oh, and there should be a 2a out in front, right? Yep. I just feel like this looks better. We're sophisticated. We're in college, right? Like, we don't use giant ass fractions anymore. So now we've got a nice inline thing. Yay. And so that rule applies no matter what A, B, and C are, even if they're complex numbers. The only thing that's going to be a challenge for us is finding that square root, but we know how to do that. So let's do an example, and then we'll work one together. And you should then be able to rock it. So here's the first one, z squared. Actually, I'll just leave this. Why don't you try this? I think this one is, I rigged these, I believe, to be sweet. We will find out. Let's do this together. You don't need to see me do it. You can plug stuff in. There's an I there. That's right. That makes it all better. I was worried. So let's see if we can do this exactly and simplify it all down using our knowledge of special triangles and a little trig. Just see how far we can get this. I'm gonna run to the restroom really fast. I'll be right back. able to make that picture there. Does anyone need me to go through how I got that picture? Got that negative 2 pi over 3? You can also do this with the rectangular approach. It just seems like it might be painful. I don't know. Is anybody going that route? Anybody going the X? Yeah. Right on. You're dedicated. That's cool. I'll be interested to see how that turns out. So are we okay in saying that this problem is actually? Oh, and what's that radius there? What is that modulus? It would be a 2D. Yes. Cool. So just first off, sketch the thing out. Notice I've got this square root of 3, so I'm thinking, oh, there's like a special triangle going on. And the special triangle, Vivian, is, let's see, so that's -1 and that's negative square root of 3 there. So I recognize that as a 30-60. And this angle here is a 60-degree angle, and that's a 30. So that means this is pi over 3 in that little pocket right here. And so this is 2 pi over 3, the complement. Does that make sense then? Yeah. And since I'm going clockwise, it's a negative 2 pi over 3. Cool. And then, yeah, I've got my radius. So this is actually square root of 2e to the negative 2 pi over 3i. And that square root is going to be square root of 2, just the square root of the modulus, e to the negative pi over 3. I just cut that angle in half. And then convert this back. So I still need to know what that is in rectangular form. The cool thing about the way Christian is going for is that there's no conversion needed. There might be other prices to pay, but there is no conversion needed. So negative pi over 3 is this one right here. So if that's negative pi thirds, that's negative 60 degrees. And I really just have this triangle again in a different situation. So that's negative root 3, that's positive 1. And so this point here, oh, and this radius is square root of 2. So I need to tweak this. So here, watch what I'm gonna do. I gotta be careful. If this was a 1 there, then I'd be good to go. But this is actually square root of 2 cosine negative pi thirds plus I sine negative pi thirds. It's always safe to go back to this. In some ways, it takes some of the thinking away from us. So cosine of negative pi over 3 is adjacent over hypotenuse, 1/2, because this hypotenuse is 2. And then the sine is negative root 3 over 2. Let me stop. Tell me if this looks cool. And we're still not quite done. We have to simplify. And this is just scratch work, right, for this piece. We still have to come back to it. So when I simplify here, root 2 over 2 minus root 6 over 2i. And that's just half of it. The other one is the minus of this, if I was looking at both square roots. But we got those covered in the plus minus here. I actually thought this one turned out prettier, but it is what it is. Are we good? Good? Okay, cool. So let's pop that. So that's scratch. So this is equal to 1/2 minus I plus or minus that beast. And then let's clean it all up. So grouping together the real stuff with the imaginary, my net real component, and here we're gonna see a plus minus kind of thing again. Ella is gonna pop out. So this is square root of 2 over 4, because I got 1/2, times that. And then the imaginary part, notice how this plus minus hits that negative, so it becomes a minus plus. So it's -1 minus plus square root of 6 over 2i. Gadzooks. I think that's right. Check me out. Check it out. Ooh, I'm missing a half too, aren't I? Yeah. So there's a half there. That's pretty nasty looking. Check, please let me know if it looks okay. Did you get the same thing from?
I had to stop. It was getting really
It was getting pretty unpleasant. Yeah.
How'd you get from there to there?
Which there? There?
The
There to
last
there?
two, yeah.
Yeah, so let me kind of back off and do it again. Let me go a little slower and more methodically. So I'll bring that 1/2 through, and then that plus minus times that minus gets a minus plus there. And I still had the 1/2 I. And now I'm just grouping together the real stuff. So this is the real part, which is a plus or minus. And then all the I stuff, Vivian, I'm just gonna group together in a parentheses times I, so it's -1/2 minus plus this √6/4.
Okay.
Does that make sense? So in the practice problem that I gave you, your final answer is going to look like this. At some point, so this is in the practice one for the quiz that's in world class. I forget what the original problem is. You're gonna get this, but this can actually be written in a very pretty way. To take this square root, I actually think that doing this route, let's talk about this for a second. So if this is z, and z is x plus iy, something, let's calm down, my God. Took 5 times longer just to write it like that. So z squared is 7 plus 24i. Z squared is this. And then when you group together, and this is what I really want to point out, and it was actually something Christian pointed out because he had been working through the whole thing. So the real part here will be x squared minus y squared always. And the imaginary part will always be 2xy. And when we set these equal, we get these. But there's one more equation. And this was the Christian's like, well, we have one more equation, don't we? Yes, we do, because we know that x squared plus y, so the modulus of this thing is the modulus of this thing. So in other words, the modulus of, wait, how did we get that? Modulus of z squared is the modulus of 7 plus 24i. Oh, there we go. Cool. So how do I get that? Well, square both sides here, so the z squared is 7 plus 24i. So that length must be this length, and that modulus of the thing squared is the square of the modulus. This is really pretty here. This is 25. So you can actually find that length out there, it's 25, so the modulus of z squared is 25. What is the modulus of z squared? It's x squared plus y squared. So we also have this equation that we can toss in. And when you do that, life becomes way better. So you can solve these two, but man, if you know this also, then look what you could do here. You could add those two equations together. The y squareds cancel and you get 32, so you get x squared equals 16, so x is plus or minus 4. Keep on rolling. Yeah. So just another way to approach it. I think I would almost not do the polar form on this one. It's pretty painful and not very pretty. So anyway, why don't we just take a little time I wanna give you time to work on stuff. I don't wanna present anything new, but I will ask you, my friends, to please read ahead for Wednesday. If you could just start reading in section 3.1, which is a very substantial section. There's a lot in 3.1. So please try to read as far in there as you can. We're gonna talk about that in great detail on Wednesday. And then we'll take like the last 15 minutes of class for our quiz. And we'll call it a day. So I'm here for consultation. See if there's anything you would like to consult about. I'll come around and chat. Or if you're done with all of this, enjoy the afternoon. That's also an option. Hi. Oh, thank you. Oh, it looks so pretty. Thank you. Hi. So, let me grab a pen. Well, here, actually, I can show you this. So if I have this, then if you take the square root of each side, think of that as this.
Oh, right.
And so it halves the angle,
Yeah.
and square root's the modulus. Yeah, that's how. Yeah, cool. And all the stuff's helping that I sent you.
Yeah.
Okay, awesome, fantastic. That's okay, as long as you got some, but yeah, okay, fantastic. Yeah, keep asking questions like that, thank you. Did you have a question? Okay, cool, okay.
At least that's what I just wrote down, so.
That's okay, you got now.
2.3, so I copied down the block from that, and I was like, yes,
We're saying
I don't know, so.
Oh, there's a
The
difference?
box that you're talking about?
Yeah, that's the box.
This is it?
That's it. Yeah.
It's nice that we don't have to paper at least.
It's the end of, yeah.
You can build memories.
Good?
So the problem that you're doing up there was 2.4.
That sounds right, yeah.
Okay, cool.
Yes, ma'am.
I was just checking. 'Cause
No,
that-
thank you. Yeah, it's
Yeah.
2.444, yes.
Cause that's the only one that I could see, but.
Just correct. Yeah, that's
This is in,
Yeah, I got this, I have 2.3.4, I
just cause I don't remember writing down the problem number, so I was like, oh, I remember there was a problem, but I couldn't. fix
Yeah,
it.
yeah. And it's crazy that the answer turns out to be as pretty as those two, right? Yeah, it's, I mean, it's crazy, but
And then I wanted to make sure that for the homework I was doing
yeah, let's talk.
the right thing, cause here, we can use any one of the methods, and I figured that was easiest, because it
figure out how to find
Oh.
Cool, yeah. That actually makes the most sense to me too, so.
Okay.
So I'm just trying to follow your flow. So
so this is just the setup.
Yeah.
Okay. Cool. What does that say? What does that mean?
I didn't know how to write like this similar
Proportional to, right? Yeah, yeah. So what we would want to do is show that each of these two sides, so that OU is some multiple of OZ,
Mhm.
but then OW is that same multiple
And I have that
of
one
Z1.
down here. Both lines have the same
Or I mean,
square.
of course, 0, 1. Yeah. Oh, okay, cool. Then that's great.
Okay, cool.
Yeah, solid.
Wonderful.
Anything else? Are you good?
And then just here, the tangent from the argument. I had like 2 lines left to write, so I didn't want to write them all. They just got shoved to the bottom.
That's good. Oh, wait, okay, got it. Okay. It's not the same problem. That's why I was like, where'd these numbers come from?
You know, just make it.
So what was the original problem? Just, oh, got it. Okay, cool. So it's out of the way. Yeah. Okay. So, yeah, and I haven't done this. This is cool. Let me just go through and see.
The angle.
Yes.
Right, yeah, cool. Thank you.
So that's negative 2 minus I. Yeah, beautiful. And 1 minus I. Yeah, it looks great. So that's arctan. Yeah, looks good.
Okay, cool.
Mm-hmm. Yeah, yeah.
I just feel like sometimes I skip through the
Is that a question?
simple
Yeah.
steps.
Yeah. Yes, ma'am.
Just wanna clarify, did we have any?
No, the 2 point, I think, yeah, 2.4 is just this stuff that we talked about, and that's what the quiz will have you do, so there's no homework out of that section. Is that
Yeah,
good?
just
That's a good
yeah.
answer?
Mhm.
Okay, awesome.
Cause I was looking at it, I said, I don't see any.
Yes, and you're correct. Doing good, Ella?
Mhm.
Anything you wanna talk about, or you cool? Looks cool.
Not yet.
All right, right on.
On that second problem. So.
Beautiful, beautiful.